Hi there, my name is Robert Sanborn. I'm a student at Western Washington University. I'm in the electrical engineering program, currently a junior. This is one of my private projects. It's a micro-hydro device. If you see here, this is a handheld hydroelectric turbine. This is just a funnel and a 3D printed cylinder. It's PLA green. But the main idea of this guy is that it's just a canister where it's submerged into water. This is actually a tub of water right now. If this device is submerged into water, water will enter through here, power this turbine. It'll generate electricity, send it somewhere else. And once it's completely full, evaporation and capillary methods will be used to remove water. I didn't get a chance to put in sponges on the inside of this guy because I started thinking about this at the beginning of fall quarter. It's now the end of fall quarter 2018. I just didn't have time to keep up with this guy because I was busy with other projects that we actually did in school. I got those done. You can actually see the videos on them as they're posted on my LinkedIn account. But nevertheless, the main idea is that this would basically be out in a large body of water, let's say the ocean. And then around 6 o'clock, when the sun's actually going down and solar panels aren't being powered, these devices would get turned on. Water would be allowed to flow through the turbine and then fill up the main chamber. And then the next day, water would be emptied out through some method, preferably mainly through evaporation, so that there's a net gain of electricity. But generally speaking, this device, the way I intended it to be used, was for storage of energy through potential energy, and then being released through kinetic energy. So basically I'm using empty space to store energy. It's just a small little idea. But in any case, if you'd like to see it in action, I'm just going to submerge it right now. And the device, if I ever did implement it, would just be tied to the bottom of the ocean floor, and it would have buoys kind of keeping it to float, so that way it would remain relatively stationary. If you look right now, I have a multimeter. It says about 24 millivolts DC. Sadly, that's not a lot of electricity, but then again, this is a very small device. If anything, I intended the device to be very large, but obviously because I can't build a 10,000 gallon canister and then stick it out in the middle of Puget Sound to test it, I had to go small, so I could manage it. But if anything, I learned, one, you need a lot of water to generate a lot of electricity that's actually useful through this project, and also well, I learned that you can't just rely on a simple evaporation. I originally had intended the water just to be evaporated over time by using reflective panels to just reflect the sun's rays and then just evaporate the water on the inside. But then I realized that that would take way too much time. That would not take just a day. That would take maybe months. Because if this was, let's say, out in the middle of the ocean, the pressure difference between the water on the inside of the canister versus the outside would just be so insignificant that it's not going to evaporate within a day. It's going to take a lot of time for this guy to evaporate. Unless, of course, some type of pump is used. My idea for right now is just using sponges, where if I put sponges on the inside of this guy, sponges would get heated up through the sunlight, and then of course as the sponges dry, water will just go right into the sponges, and then that just creates a capillary action. It was actually an idea of one of my professors. Anyway, hope you enjoyed.